Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions from May June 2023, paper 4, variant 2. In today's lesson, we will talk about radioactivity, space, and universe. As always we do, we will discuss these questions in detail so you can improve your conceptual understanding of these topics and also you can have better understanding of these questions. Let's study together, let's improve together. Question 9, part A says table 9.1 shows some properties and values for alpha particles, beta particles, and gamma radiation. Complete table 9.1. In order to answer this question, first of all, we need to understand properties of alpha particle, beta particle, and gamma radiation. Let's try to understand the properties of these particles and radiations. We have alpha particle, and alpha particle is simply a helium nucleus. So very important point, you need to understand what is alpha particle. Alpha particle is just simply a helium nucleus. So it has no electrons. And alpha particle, it consists of two protons because atomic number is equal to 2. It means it has two protons. And mass number is equal to 4. So 4 minus 2 is equal to number of neutrons. So it has 2 neutrons. And charge on alpha particle is equal to plus 2e. This is equal to the charge on two protons. And elementary charge 1e, this is equal to 1.6 times 10 to minus 19 coulombs. Now let's try to understand beta particle. Beta particle simply means that we are talking about electron, fast moving electron. So beta particle is simply fast moving electron. So this point is important. You need to understand what is beta particle. So as it is fast moving electron, it means no protons and no neutrons. And charge on this one, charge on electron is minus e. It means this is minus 1.6 times 10 to 19 minus 19 coulomb means negative charge on beta particle. And gamma particle, it has no charge and it has no proton, no electron. So proton, number of protons equal to 0. It has no proton and it has no neutron. And the charge on this one also is equal to 0. We can say Q, this is equal to 0. How we can stop this one? Because we have to write down here how we can stop gamma particle. Gamma radiation, in fact, not particle. Gamma radiation can be stopped by very thick wall. We can say very thick wall of concrete, or we can say lead. So this is how we can stop gamma radiation. Now let's try to fill this table, complete this table now. Alpha particle number of neutrons, it consists of 2 neutrons as we have written here. Beta particle number of protons 0, so we have written here. So it has 0 number of protons. Charge on beta particle, charge is equal to this. So simply we can write it here. So this is minus 1.6 times 10 to minus 19 coulombs. Gamma radiation number of neutrons 0, charge 0. So that's all what we need to do to answer part A.
Part B says state how beta decay changes the nucleus of an atom. So first of all, let's try to understand beta minus decay. Beta minus decay. Let's say we have nucleus X. It decays into nucleus Y by emitting beta minus particle. If beta minus particle, it means there is also electron anti-neutrino. But for this question, simply we need to understand the change in the nucleus of an atom. This nucleus, imagine that it has atomic number Z and it has mass number A. So when beta particle is emitted, atomic number of this one will increase by 1, but the mass number will not change. It simply means that one neutron changes into proton in this decay. Neutron changes into proton. It simply means that proton number increases. It has one more proton and it has one less neutron. So one less neutron. Neutron number decreases. So we can say one more proton in nucleus Y. So we can say one more proton and one less neutron. So this point you have to write down, and this is how you can answer this question. So simply you have to understand how the proton number is changing and how the mass number remains constant. So if mass number remains constant, proton number increased by 1, it means 1 proton changes into 1 neutron. So this nucleus has 1 extra proton and 1 less neutron. Part C says a radiation detector used in a laboratory detects a background count rate of 30 counts per minute. A radioactive source is placed in front of the radiation detector. The initial reading on the detector is 550 counts per minute and half-life of the source is 25 minutes. Calculate the expected reading on the detector after 75 minutes. So first of all, we can write down, for this question we have value of background count rate. So we can write down background count rate. Very important point, step by step you need to understand. It's a beautiful question about half-life. We can also say this is a typical type of question, or we can say it's a difficult question on half-life. We have background count rate that is equal to 30 counts per minute, and this count rate is always present. So we have 30 counts per minute. We also have initial reading. So this is initial reading on detector. So we can say initial reading on detector. Initial reading on detector is equal to 550 counts per minute. Counts per minute. From these two informations we can find out initial count rate due to source only. So we can say initial count rate due to source only. Due to source only. We have total count rate that is 550. So if we minus background minus 30, so in this case we will get 520 counts per minute. So this is due to the source. And we have 75 minutes. It is given to us total time 75 minutes, and 75 is equal to 3 times 25 minutes. 25 minutes, and 25 minutes is 1 half-life. So it means we have 3 half-lives. So we can write down number of half-lives. Number of half-lives. Number of half-lives in this case will be equal to 3 half-lives. So now we can write down final count rate. Final count rate due to source only. Final count rate due to source after 3 half-lives. Final count rate due to source only, or you can say after 3 half-lives. And this one has to be equal to 520 multiplied by 1 by 2, 3 times 1 by 2, and 1 by 2. So it simply means that we have to divide this one by 8, and if we solve this one we will get 65 counts per minute. 65 counts per minute. So this is due to the source only. But question is asking us expected reading on the detector. Reading on detector. So we can write down reading on detector. Actually this is expected. Expected can be a little bit plus minus because decay is random. So that's the reason they have written expected reading. I'm writing reading on detector. Reading on detector. So the reading on detector has to be equal to final count rate. We have 65 plus background. Background is 30 counts per minute. So final reading will be 95 counts per minute. A beautiful question. Try to understand this one step by step. So we have 95 counts per minute. So the final answer we need to write on here 95. So this is how you need to answer. It's a beautiful question. Try to master this. Part D says state 2 safety precautions taken when moving, using or storing radioactive sources in a laboratory. First of all, moving. So when we want to move radioactive sources, we should wear gloves. We can write on the first one, wear gloves. Wear gloves. So 1 point second, you can also say use tongs. Don't touch radioactive sources directly. When using radioactive sources, keep distance. Keep distance from sources. We can say keep distance from sources. Keep distance. The second point we can say limit time of exposure. Limit time of exposure means don't stand in radioactive source room for long time, or don't do radioactive experiments for long time. So limit time of exposure. Storing, and we should store actually radioactive sources in lead boxes, or we can say in lead containers. For this question you need to write only two of them, so you can write on two of them for the answer of this question. So we have talked about five, so you can write on any two of them. Question 10 part A says, state the equation that defines the average orbital speed of a planet. State the meaning of any symbols you use. Orbital speed, and orbital speed simply equal to the distance traveled by planet in one rotation divided by time taken divided by time. And distance traveled by a planet in one rotation, or we can say in one cycle, that is equal to circumference of the circle divided by the time period, time taken to complete one cycle. We need to write down the meaning of this symbol. What is R? This is average. This one is average radius of the orbit. Average radius of the orbit. And T is the time period. We can say this is orbital time period, or we can say this is orbital period. So this is how we can answer question 10 part A. Part B says, suggest why countries that are a significant distance from the equator experience significant temperature variation throughout the year. For that purpose we need to understand that rotation axis of our planet is tilted. As you can see here, rotation axis of our planet, this is tilted. As rotation axis of the planet is tilted, so the sun rays from the sun, they reach countries above equator and below equator at different angles throughout the year. So as angle change, the amount of light coming from the sun, it's spread over different area. Let's try to understand what exactly it means. You can do this experiment by yourself. First of all, you have the light source. It is at an angle of 90 degree to the surface like this. Actually, this is happening at the equator. You can also see here. So light is concentrated in this smaller part. But as angle change, you can see the light spread over larger area. So this part will be colder. We can say this will be cold as compared with this one. So this will be hot. But at equator throughout the year, angle is the same. So the change in temperature is very small. So you can see with this demonstration as well. So light will concentrate at this area. If we change the angle of the light, you can do it by yourself. Now this angle is 45 degrees. In this case, you can see the same light, it's spread over larger area. So in this case, intensity of the light will go down, so the temperature will decrease. So as this angle keep on changing, the spreading of the light over area will be different. It will spread small area, it will spread on large area. Based on that one, there will be variations in temperature. So these are the points we need to understand. But if you look at equator means this part, this always remain at almost the same angle. So you can see this almost remain at the same angle. You can see here almost this part always remain at the same angle almost, and this part also on other side also remain at the same angle, mean opposite side of this one. So the temperature at equator, like Singapore, there is no big variation in temperature. So temperature almost remain same. So it is just simply due to angle, and that is due to rotation axis of the planet that is tilted. You can also understand from here. So let's say this is our planet. So here is equator, and here is North Pole, and here is South Pole. So it is tilted like this. So here rays will spread over larger area, so this will be colder, and this one will be hotter because this will be closer, and so on. So these points you need to understand. I hope this is clear. So now let me show you how you can write down your answer. For the answer of this question, you can write down these points. You can say rays from sun strike the countries at different angles throughout the year, and this is due to tilt of our planet about its rotation axis. So the rotation axis is tilted from the vertical. Part C says fill in the gaps in the paragraph about a star much more massive than the sun. Means we are talking about more massive star. If you look at this diagram, you can see we have sun-like stars, they follow this cycle, and we have more massive stars, they follow this cycle. In the question, it is given to us the stage that follows a stable state in the life cycle of the star is the stable state. More massive star, when they reach this stage is the stable state in the life of more massive star. So this one is the stable state. So simply you need to write down supergiant, red supergiant. So you can say this is red supergiant stage. Then it is given to us it explodes as a supernova to form. So it explodes as a supernova and it forms nebula. So the next stage is nebula, after explosion, nebula. And after nebula, this leaves behind a neutron star or black hole. It depends on the mass of nebula. So we can write down here. So we have neutron star, or there will be black hole. It depends on the remaining mass. So this is black hole. Part D says a galaxy is moving away from the Earth with a speed of 33,000 kilometers per second. The value of the Hubble constant is 2.2 times 10 to minus 18 per second. Calculate the distance from the galaxy to the Earth. Give your answer in light years. So answer has to be in light years. So this is very important point. And we need to understand 1 light year. So first of all, let's try to understand 1 light year. 1 light year is equal to 9.5 times 10 to 15 meters. So this is important point you need to understand. So simply we need to use Hubble's law. According to Hubble's law, V is equal to h naught times t. So we need to find out distance in this case. So for the distance, simply we can write down this is V divided by h naught. The value of V is given to us, that is 33,000 kilometers, so we can convert this one into meters, divided by value of h naught, that is 2.2 times 10 to minus 18 per second. So if we solve this one, our answer will be in meters, but we need our answer in light years, so we will divide this one by 9.5 times 10 to 15. Now if we solve this one, we will get 1.6 times 10 to 9 light years. So this is our final answer, and this is how we can approach this type of problems. So the main point is we need to understand 1 light year is equal to this, the relationship between light year and meters. And that's all for today's lesson. I hope this video was helpful. If you have any questions, please leave questions in comments and I will try to answer as soon as possible. And also, if this video was helpful, please like and subscribe because your encouragement is very important. See you in next video.